Hey, okay, so lesson 4-2, straight line motion, connecting position, velocity, acceleration. There's some really, really good questions and examples on this that match a lot of the things that you'll see on the AP exam. So this is really, really good. And so a little vocabulary review here. Position could be any of these things. Notice the variable time. Average velocity is not calculus. That is old school slope. So average velocity is old school slope. Instantaneous velocity is calculus. That's the derivative. And notice the different formats here: dSdt, s prime, v of t, or the limit definition. Speed is the absolute value of velocity. Acceleration is the second derivative. Look at the notations there all the way across. Displacement is the difference between your two positions. Distance traveled would be the sum of the absolute values of the distances between turning points. Free fall is we have the gravitational constant here. There's time, initial velocity, initial position. Directional change is when the velocity changes from negative to positive or positive to negative. And then your gravitational constants are here. All right, so here we go. Very first one says particles moving along the x-axis so that at any time t greater than or equal to 0, the position is given. She does make a note up here that these are they're very much like what you would see on the AP Calculus exam. Registered trademark. At t equals 0, determine whether the particle is moving left or right. Okay, so that's about its velocity. If the velocity is positive, it's moving to the right. If the velocity is negative, it's moving to the left. So we have to find the velocity. Well, the velocity is going to be the derivative of your position, and the position is given as x of t. So x prime of t then. So x prime of t, all right, is going to be 3t squared minus, if you do the power rule here, the 2's will cancel, and so you'll have 9t minus 12. All right, and there we go. And so then it's asking what's happening at 0. So x prime of t when t is 0 is going to equal negative 12. And in this particular case, we're not given any units or whatever. So it's just negative 12. And so that means, and I will type this part. Let's see here. Therefore, here we go. Since the velocity of the particle at t equals 0 is negative 12, whatever units that is, the particle is moving to the left at that moment. Oh, okay, good. And it says, what time does the particle change directions? Okay, well, for a particle to change direction, the velocity has to go from negative to positive or positive to negative. But in between those two, it would have to be equal to 0. So I need to find out the moment when it stops. Because then if it stops, it could possibly change directions. All right, and so we're going to find out if that actually happens. All right, so here we go. So I want to know then, the question is, when is x prime of t equal to 0? Because that would be the moment it stops and possibly changes directions, okay? So it wants to know when 3t squared minus 9t minus 12 is equal to 0. Minus 12 equals 0. Sorry, put the equal sign in there a little too early. All right, and so that's a minus. All right, I could divide everything by 3. So let's do that, and that'll give me t squared minus 3t minus 4 equals 0. And that factors. And so that factors into t minus 4 times t plus 1 equals 0. And those two moments would be when t equals 4. I don't even know what that's about.
What?
Dang it. All right, whatever. All right, t equals 4.